Addition of fractions and mixed numbers. We're on Unit 5, Lesson 3. In this lesson, we're going to be able to solve problems involving the addition of fractions and mixed numbers. We're also going to be able to use equivalent fractions as a strategy to add and subtract fractions. Let's take a look at some vocabulary before we begin. Remember, a common denominator for two or more fractions, it is a number that is a multiple of both or all denominators. For example, the fractions 1/2 and 2/3, they can have a common denominator of 6, 12, and 18, and so on. If the fractions have the same denominator, that denominator is called a common denominator. Remember from lesson 2, our quick common denominator, or QCD, that is the product of the denominators for two or more fractions. For example, the quick common denominator for 1/4 and 3/6 would be taking 4 times 6, because the denominator is 4, the denominator is 6, and we get the common denominator of 24, or the QCD 24. As the name suggests, this is just a quick way to find a common denominator. It's not always the least common denominator. Equivalent fractions rule. Remember, that is a rule stating that if the numerator and denominator of a fraction are each multiplied or divided by the same non-zero number, the result is a fraction equivalent to the original fraction. Let's open up our Math Journal 2 to page 160. The math message is on page 160, and again, we're in Math Journal number 2. Choose the best estimate for each problem. Then write the answer for any problem that you solve mentally. For number 1, we have 2/5 plus 1/4. Doing mental math, think about what would your estimation be, and then write the answer for them if you can solve them mentally. What if they don't have the same denominator? What should you do? Think about what we did in lesson 2 and what we will be doing again in lesson 3. Number 2, you have 1/9 plus 4/9 plus 3/9. And for number 3, you have 3/4 plus 5/8. So take some time, solve them. If you can solve them mentally, write your answer down. Don't forget to do your estimate. And then come back and we'll check our work together. All right, for number 1, the answer could be 13/20. 20 is the common denominator, and your estimate should be about 1/2. Number 2, you can mentally solve this. You already have the same denominator all the way across, so you just have to add 1 plus 4 plus 3, and you get 8/9, and you see the estimate is about 1. And finally, number 3, the estimate is a little bit more than 1. If you added these together, you could get 11/8, because 4 can become 8, or you can turn this into the mixed number and get 1 3/8. So it's just a little bit more than 1. We got 3 more here to do. We've got problems 4, 5, and 6. You'll see they're written a little bit different than our previous ones. 1 through 3, they were written horizontally, and 4 through 6 are written vertically. So you'll see number 4, you've got 2 4/5 plus 1 2/3. Number 5, 2 1/16 plus 5 1/16. And 6, you have 2 7/8 plus 1 3/8. Don't forget to do your estimation and solve them if you can. Okay, by now you should have solved 4 through 6. You can see that number 4's estimate should be somewhere between 4 and 5, with an exact answer of 4 7/15. Number 5 should be a little bit more than 7, with an exact answer of 7 2/16, or you could say 7 1/8. And number 6 was a little more than 4 of an estimate, and you get 4 2/8, or 4 1/4. If you were able to reduce the fractions in the mixed numbers for 5 and 6, give yourself a pat on the back. Nice job. Remember that when estimating sums and differences, you must look at the whole number and the fractional part of the mixed number. So today we're going to explore how to use common denominators and other familiar strategies to add mixed numbers. So when we take a look at numbers 2, 5, and 6 that were part of our um, math message, why were these problems easy to solve mentally? Take a look at them. What would make them easier than the others? Hopefully, you said because their denominators are the same. In number 2, all the denominators are 9. In number 5, both denominators are 16. And in number 6, both denominators are 8. That makes it easy. We don't have to do any other steps. We can just jump right in and do our addition. In problems 1 and 6, we see we've got 2/5 plus 1/4, and then in 6, we've got 2 and 7/8 plus 1 and 3/8. How are these problems similar to problems we have solved before? How are they similar? Think to yourself, ask yourself that question, see what kind of answer you come up with to help you in your thought process here. What did you get for an answer for these questions? That is another question to help you in guiding your reflection and your thinking here. What strategies did you use to solve these two problems? Did you do anything special? Well, here are some strategies for the first problem. Let's take a look at these. Let me get these cleared off for us. You'll see for problem 1, we've got 3 different strategies you could do. The first strategy would be to find a common denominator for 2/5 and 1/4. So in this case, the quick common denominator, or the QCD, would be 20 because 5 times 4 is 20. That's a good choice. You could also use multiplication rule. So you could rewrite each fraction as an equivalent fraction with a denominator of 20. Take a look here. You can take 2/5. You can take both the numerator and the denominator times 4. So you'd have 2 times 4 is 8, 5 times 4 is 20. So you get a new fraction of 8/20. 1/4, you could take 1 times 5 is 5, 4 times 5 is 20, and you get 5/20. And then you can add the fraction with the like denominators. 8/20 plus 5/20 equals 13/20. Let's look at strategies for problem number 6. Okay, for problem number 6, the first step you would take is to add the whole number parts. You could take 2 plus 1. Then you're going to add the fraction parts, 7/8 plus 3/8. So in here you see you get 3 and 10/8. That's an improper mixed number. So you can rename 3 and 10/8. What you can do is you can start with the 3 wholes and say that you've got 10/8. Write a 3 to show the 3 wholes and show 10/8. You can make a group of 8/8, and then you have 2 left over. You can trade this 8/8 right here that you can see in the circle for 1 whole. Now you have 3 wholes plus 1 whole and 2/8. Or you can say 3 plus 1 and 2/8 equals 4 and 2/8. Taking a look at number 3, we had 3/4 plus 5/8. How did you solve this problem? What strategy did you use? The first thing you should have done was find a common denominator and add it, as we did in problem number 1. Then rename your answer just like we did in problem number 6. So in this problem in number 3, you were kind of incorporating both parts that we did in 1 and 6. So you will now use the strategies you reviewed for problems 1, 3, and 6 to then solve a more complicated problem like this one in number 4. 2 and 4/5 plus 1 and 2/3. So we're not only needing a common denominator, we're also going to be adding the whole numbers and renaming the improper mixed number. So you want to ask yourself, is this problem easy to solve mentally? Why or why not? I'm going to go with no, because I need multiple steps to do this one. But we can still use the same strategies that we did in 1, 3, and 6 to help us solve problem number 4. So what we did in problem 1 was find a common denominator. And we still need to do that for problem number 4. So taking a look at problem number 4 here, more in depth, you want to find your common denominator for the fraction parts of the mixed numbers. The quick common denominator is 15, and that's a good choice. You can rename the fraction parts so that they have the same denominator. So we're going to take 2 and 4/5. We're going to multiply the 4 times 3 and the 5 times 3 that's in that fraction. And you rename your mixed number as 2 and 12/15. Then we're going to do the same thing for 1 and 2/3. This time you're going to multiply the numerator and the denominator by 5, and you get 1 and 10/15. Then you're going to add the mixed numbers with the like denominator. So now you're going to take 2 and 12/15 plus 1 and 10/15, and you get an answer of 3 and 22/15. Is 3 and 22/15 our final answer? No, it's not. What you need to do is use the strategies you used in problem number 6 to rename your improper mixed number. So what you're going to do, rename that sum. You've got 3 and 22/15. We're going to take 3 plus 15/15 because we know that equals 1. And then you got 7/15 left over. So what you're going to do is have 3 plus 1 plus 7/15, and we get a final answer of 4 and 7/15. So questions you can ask yourself whenever you are tackling a new problem. Got about 5 questions here that you should use to help you in your reflecting, in your thinking, and in your problem solving. What is a good estimate for this problem? Can I solve this problem mentally? Do I need to find a common denominator? Does my answer include a fraction greater than 1? Should I rename it so that it's a smaller fraction? And does my answer make sense based on my estimate? Use these questions to help you and guide your thinking on these next problems that we're going to do in Math Journal 2 on page 161 and 162. Let it load. There we go. So on problems 1 through 4, you are going to do exactly what we just talked about. You're going to estimate each sum, and then you're going to solve it. Make sure you show all of your work so you can refer back to it. So you can see problems 1 through 4 here. All of them have mixed fractions or mixed numbers. Number 1, 3 and 4/7 plus 4 and 4/7. Take note that that has the same denominator. It already has a common denominator there for you. Number 2, 6 and 3/4 plus 1/6. What are we going to do? What steps? What's your first step for that problem? Number 3, 7/8 plus 1/6. And number 4, 7 and 2/3 plus 2 and 3/5. Take a moment, work on problems 1 through 4, pause your video, and then come back and check your work here. Number 1, you can see the estimate is about 8, and the reason they did this was because 3 and 4/7, we could round that up to 4, and then 4 and 4/7, it'd be about 4, 4.5, and so they're just saying, okay, the answer is going to be around 8, and you can see that they took 4 plus 4, which would be 8/7, and they did 3 plus 4, which is 7. So what you actually had here was a 7 and 8/7, and then they took out 7/7 because 7/7 equals 1, and they put that 1 right here into the whole number, and they were left with 8 and 1/7. Number 2, the estimate was a little less than 7 because we see that we took 6 and 3/4 plus a very small fraction of 1/6. So we're just a little bit less than 7, real close to it. And the answer is 6 and 11 twelfths. So you can see that they did not use the quick common denominator. They found their least common denominator. They took 4 times 3, which is 12. They took 6 times 2, which is 12. And they got a final answer of 6 and 11 twelfths. Number 3, their estimate was a little more than 1. You can see they found a common denominator of 24. They did not do quick common denominator because 6 times 8 is actually 48. So they found their least common denominator of 24, and they got an answer of 1 and 1/24. And 4, between 10 and 10 and a half was an estimate. You can see they found a common denominator of 15. They did 3 times 5, which would be a quick common denominator for this one, and it resulted in 10 and 4/15. Let's look at number 5 now. It says for each number story, write a number model with an unknown and make an estimate. If you've noticed that estimates are huge with this, it helps us know if we're on track, just like we've done previously in other units when we are adding, subtracting, multiplying, dividing. So then you're going to solve the number story and show all of your work. Record your answer and a summary number model. Use your estimate to check whether your answer makes sense. That's why we do it. So number 5, Mr. Kumar's class ate 6 3/4 pizzas, and Miss Reinhardt's class ate 4 2/4 pizzas. How many pizzas did the two classes eat? First of all, you want to ask yourself, what kind of math are you doing here? Don't forget to use cubes. Circle your numbers. Underline your question. Box in those key words, and then evaluate and solve. And then check your work with that estimate. I'm going to read through all the number stories, and then we'll come back and check. Number 6 says Melanie's superhero costume for the school play requires 1 5/6 yards of green fabric and 1/3 yard of yellow fabric. How many total yards of fabric are needed for the costume? Again, use cubes. Think through this. Look at your denominators. Are they the same? Are they common? Or do you need to create common denominators? And number 7, Charlotte ran 5 2/3 miles on Monday, 1 5/8 miles on Tuesday. How many miles did she run in all? So go ahead and pause the video, work on 5, 6, and 7. We'll come back and we'll check these together. Number 5, our number model should have been 6 3/4 plus 4 2/4 equals P. We put P for pizza. The estimate is about 11 pizzas because when I take a look at that, I can see 6 plus 4 is 10. And then I see that 3/4 and 2/4, both of those are a half or more. That give me around 11 pizzas. You can see my sample work here. We got 10 5/4. So we took 4/4 out of 5/4. So we've got 10 plus 4/4 plus 1/4. That equals 11 plus 1/4, which equals 11 1/4. So our answer, this is written wrong. We did not, it should be 11 1/4 pizzas written there. And the summary is 6 3/4 plus 4 2/4 equals 11 1/4 pizzas. We would never say, I ate 1 11/4 pizzas, would we? So it's always good to check to see the answer. Does it make sense? And if that's not how you would write it, or that's not how you would say it in conversation, then you want to fix it. You want to say 11 1/4 pizzas. Number 6. The number model is 1 5/6 plus 1/3 equals F for fabric. You can use any other variable letter you would like to use. Our estimate was a little more than 2. You can see our work here was 1 5/6 plus 1/3. Take a look, we only changed 1/3 because the 3 can turn into a 6. That's our common denominator. And so we took the numerator and the denominator times 6. We got the new problem of 1 5/6 plus 2/6. You can see that right here. And we got 1 7/6. 1 7/6 is still an improper mixed number. So you can see the thought process here of taking out 6/6. So it's 1 plus 1 plus 1/6 gives us an answer of 2 1/6 yards. And then you can see our summary model.